So now the next item, the next type is, I told you this third type is asymptotes of the hyperbola. So the 10 marks in analytical geometry, as I told you, one comes from the arrow scope problem, that is your eccentricity, finding the eccentricity, foci and vertices and so on. The second one is practical problems, what we have discussed earlier. Now we are going to see about the asymptotes of the hyperbola, asymptotes of the rectangular hyperbola. This is the third section, which may comes for your board examination from this part. I am surely telling you this is one of the all-time question. Whenever if your next generation comes also, this question will be there in your higher secondary second year. So be careful of that. So these two questions what I am going to discuss now is very, very important, so important. In exam point of view, it's very important question. Okay. Now let's see the first one in the asymptotes. Find the equation of the hyperbola if its asymptotes are parallel to x plus 2y minus 12 equal to 0 and x minus 2y plus 8 equals to 0. 2, 4 is the center of the hyperbola and the hyperbola passes through 2, 0. Now it is first line, it is given that the two lines are parallel to its asymptotes. So therefore let us find out the lines parallel to asymptotes. The lines parallel to asymptotes are given. What are the two lines? X plus 2y minus 12 equal to 0 and x minus 2y plus 8 equals to 0. Now I am going to find out the equation of the asymptotes. So you know how to find, if it is ax plus by plus c equal to 0 is given, the parallel line is said to be ax plus by plus k equal to 0. Therefore I am writing the equations of the asymptotes are, the equation of the asymptotes, the equation of the asymptotes are, you can write this one as x plus 2y plus L equals to 0. And again next one you can write this as x minus 2y plus m equals to 0. Because these lines, given lines are parallel to the asymptotes. Therefore the equation of the asymptotes you can write this as x plus 2y plus L equal to 0 and x minus 2y plus m equal to 0. And the second line of the question is given 2, 4 is the center of the hyperbola, which means that we can say it passes through the center, it passes through the center, it passes through the center, what? 2, 4. Which means we are substituting x is equals to 2 and y is equals to 4, we will get 2 plus 4 2s are 8 plus L equal to 0. Here we have 2 minus 4 2s are minus 8 plus m is equals to 0. From this I can say L is equals to minus 10 and from this I can say m is equals to 2 minus 8 minus 6, therefore we will have plus 6. So you can substitute in the above equation, we will get therefore the required equation of the asymptotes are, required equations of the asymptotes are x plus 2y plus L, sorry, what is the value of L here? Minus 10, therefore you put minus 10 is equals to 0 and x minus 2y plus 6 equals to 0. Now this is called a separate equation. Now I am going to write the combined equation. The combined equation of the hyperbola, combined equation of the asymptotes. Combined equation of the asymptotes is x plus 2y minus 10 into x minus 2y plus 6 equals to 0. As I told you in the earlier, that is the rectangular, the equation of the asymptotes and the hyperbola differs only by a constant. In this question, according to this question, you are going to find out the equation of the hyperbola. Listen to it. Therefore, I am going to write the equation of the asymptote, equation of the hyperbola as the equation of the hyperbola. Then you can write is x plus 2y minus 10 into x minus 2y plus 6 is equals to k, constant k. Okay, as I said earlier, it is differ only by a constant. The equation of the hyperbola and the equation of asymptotes are differs only by a constant. I told you, right? Now you can write this as, it is given in your problem, and the hyperbola passes through 2, 0. The hyperbola passes through 2, 0. Your hyperbola passes through 2, 0. Now you substitute x is equals to 2 and and y equal to 0 minus 10 into x is equals to 2 minus 0 plus 6 which is equals to k. Therefore 2 minus 10 which is equals to minus 8 into 8 is equals to k. Therefore your k is equals to minus 64. Substitute your k is equals to minus 64. Therefore the equation of the hyperbola is therefore the required equation of the hyperbola is x plus 2y minus 10 into x minus 2y plus 6 is equals to minus 64, or you can write this as x plus 2y minus 10 into x minus 2y plus 6 plus 64 is equals to 0. So with this we are getting the equation of the ellipse. So see, listen here, it is given that the two equations of the asymptote which are parallel to the lines given, we are converting into parallel lines into the asymptotes. Therefore, as I told you that ax plus by plus c equal to 0, then the parallel line is ax plus by plus k equal to 0. Similarly, we are converting this parallel to asymptotes. We are getting the values of n and m using it is given in your problem. The center of the hyperbola is 2, 4. We are substituting the values. We are getting the values of L and M. Substituting that, we are getting the required equation of the asymptotes. To find the equation of the hyperbola, you know that they are differ only by a constant. Therefore, we are adding a constant k. That is x plus 2y minus 10 into x minus 2y plus 6 equals to k. Therefore, again the hyperbola passes to 2, 0. From that I am getting k is equals to minus 64. Substituting in the required equation, we will get that the required equation of the hyperbola is x plus 2y minus 10, x minus 2y plus 6 plus 64 equal to 0. Okay.